Good morning, all the students. Welcome to Storage Area Networks course. Now let me know what made you opt for this course first so that I can understand what are your expectations. Accordingly, I will try to deliver my class, right? So, Sunil,
Ma'am.
so what is your idea about this course? Why did you opt for this? Just for scoring marks?
No, ma'am. It have a wide scope in future. So,
Okay, wide scope. How many of you have the passion to know about this course? Study this course? Because this is a good option, I feel. I'll tell you why. Asta, Pavitra, all of you know what is the content of this course. You have gone through, right, before opting for this?
Yes, ma'am.
Yes, ma'am.
Okay. So this course mainly deals with how to manage the data center. You know what is a data center, right?
yes, ma'am.
Yeah. Can any one of you explain what is a data center? During big data analytics course also I have explained you, right? To store large amounts of data, large volumes of data. We need data centers either within the organization or they can outsource it and data storage provided as infrastructure over the cloud, right? So if you want to start an organization, you will be generating some data. So when you generate the data has to be stored somewhere in order to analyze. And older data have to be archived and newer data have to be quickly, it should provide us the ability to be quickly accessed. Only then that data can be efficiently analyzed to draw insights about what the customer feels about the organization. That will actually help the organization to take important decisions, informed decisions about what to plan in the future in order to stay ahead of their counterparts in the market as well as to meet their customer expectations according to their changed interests, right? Now, data center is a place where large amounts of processors are stored in which the data can be, large amounts of nodes can be, data nodes can be stored in which the data will actually be hosted. Now, I'll just show you how a data center looks like and what you wanted to do. First of all, if you want to understand about storage area networks, if you are a data center manager, you're like a doctor for the data center. Say, human body anatomy, if you take. Doctors study about how different organs of the body function. And you, by studying about this, by understanding the concepts of this course, you're trying to become a data center manager, means a doctor for the data center, where you will understand each and every functionality that exists in a data center. So how is the data stored? How is the data split? How is the data replicated in order to ensure continuity in the business cycle? So what do you mean by business cycle? Or how important data is for any organization? Say the organization's data is stored in the data center and the data center is down for some time. And whenever some clients are trying to access the data and it is not available, that is an interruption to the business cycle. So they should not have any interruption in the business cycle. Data should be available 24/7, 365 days. In order to ensure that kind of business continuity, data centers have to work very efficiently and effectively so that it will not cause any interruption to its clients. Data centers clients are organizations or individual people who generate large amounts of data. So when they want to access their data and they find some downtime in the functionality of the data center and the data is not accessible, that is not a good what to say scenario, right? So in that cases, you have to, in the data centers have to ensure continuous access to the data. Business continuity must be ensured by the data centers. So do you know any organizations that are providing storage as infrastructure? Can you name one or two organizations? Kishore?
Amazon,
Yes, Sunil, tell me.
Amazon, Microsoft.
Microsoft give their storage as infrastructure. They provide services of storage.
Yes, ma'am.
Okay. Guria, can you name one?
Google.
Right. Deepika? Yes, Pavitra? You heard about AMC Square? Not Einstein's formula. AMC Square is a company. You heard about it? AMC Square, NetApp. All these are into business of providing storage to the data generated by organizations. So they sell the data storage space. Okay, so they have clients across the globe who try to who actually want data storage space and store their data and have access to it whenever they want. Again, the data value keeps changing along with time. If the data is generated today, it will be more valuable. But the data generated before some 100 days or before 1 year will be lesser valuable. For this, can you give any example, Asta? How the data's value change over time? Asta, you're there?
Yes, ma'am.
In the college backdrop, college scenario, the data about current students is more valuable to us, whereas considered to the alumni, it is lesser important, right? So if we want to, or if you take a car selling companies, there the customers' data, new customers' data is more important in order to say provide some servicing, yearly servicing, or in order to recommend some insurance policies to them, vehicle insurance policies. In such terms, it is important. But 10 years old customer data or 20 years old customer data, it is not that important. And frequently, we may not access that kind of data. In such cases, we archive the data and access it whenever it is required in order to save the storage space. Generally, the more important data is stored on primary memory or quickly accessible secondary memory. But when we take other kind of data, which is old data, that have to be archived in some storage devices, but kept in a library which can be quickly accessed whenever the need arises. Okay, so all this you're going to study how the data value is decided and where the data is stored according to its value, how the data is written onto the disks by locating the appropriate track, by locating the appropriate sector. All this you're going to learn in this course. Because you're a doctor of data center, you need to understand each and every core level of anatomy in the data center. So if you want to store the data, if you want to write the data onto the disks, then how the read-write header, say a read-write header looks like this, where you have a disk. And in order to take this read-write header, place it on the appropriate track and onto the appropriate sector to write the data or read the data, how it actually works and how to manage the data replication. Say sometimes the data seems to be very valuable to some organizations. It is like critical data, which they can't afford to lose at any time. Right? In such cases, the data has to be replicated with better replication factor. Say replication factor should be 3 or 4, means 4 copies of the data has to be maintained. Now, when they are replicating the data, what type of replication it should be? Whether it should be stripping, or whether it should be mirroring, or whether it should be, say, just the parity, storing the parity. So that for the data, you just calculate a parity and store the parity so that by accessing the parity, you can get back the entire data. Right? So what type of replication you need to provide to the data? Depending on the criticality of the data, importance of the data for that organization, you need to decide what should be the replication mechanism and what should be the replication factor and how the data has to be stored in duplicate copies and on which type of architecture it can be stored. All these are going to be dealt with in this course. And in order to ensure the business continuity, what is the business cycle? What is the business cycle for a data? And how you are going to ensure the business continuity of your clients so that they don't encounter any interruption in the access to the data. Right? All these you are going to take up such responsibilities as a data center manager. So if you are learning this course by interest in the subject, with passion, this is a very, very good course. Okay, you're going to learn very interesting things rather than learning it for the sake of marks or just for the sake of taking some electives. If you have interest in this course, you'll enjoy the journey throughout the course. Now I'll just show you how a data center looks like and we'll have some discussion on that.
A data center is the brains of the internet, the engine of the internet.
It is a giant building with a lot of power, a lot of cooling, and a lot of computers.
It's row upon row upon row.
Are you able to see this? Can someone confirm?
Yes, ma'am.
Of machines, all working together to provide the services that make Google function.
I love building and operating data centers. I'm Joe Cava, Vice President of Data Centers at Google. I'm responsible for managing the teams globally that design, build, and operate Google's data centers. We're also responsible for the environmental health and safety, sustainability, and carbon offsets for our data centers. This data center in South Carolina is one node in a larger network of data centers all over the world. Of all the employees at Google, a very small percentage of those employees are authorized to even enter a data center campus. The men and women that run these data centers and keep them up 24 hours a day, 7 days a week, they are incredibly passionate about what they're doing.
In layman's terms, what do I do here?
I typically refer to myself as the herder of cats.
And I'm an engineer, hardware site operations.
We keep the lights on, and we enjoy doing it.
And they work very hard. So we like to provide them a fun environment where they can also play hard as well.
We just went past the 3 million man-hour mark for zero lost time incidents. 3 million man-hours is a really long time, and with the number of people that we have on site, that is an amazing accomplishment.
I'll just share one more video. This is more about Google's work environment.
My job is to make college easier because students have a lot of fun.
What is a data center? A data center is a technical facility that houses an organization's IT operations and equipment, where it stores, manages, and disseminates data. Data centers house and networks most critical systems and are vital to business continuity and operations. Consequentially, the efficiency, optimization, reliability, and security of data centers and their information is of critical importance to today's business. The data center may vary depending on its primary function, but typically it is supported and managed by one of the following four categories. Enterprise, multi-tenant data center and co-location facilities, hyperscale and cloud, carrier and service provider. Within the data center, the following technical spaces and subsystems are managed by the operations staff: physical security systems, network and IT systems, power resources, environmental control, performance and operational management. These subsystems can be translated into the following challenges: risk management, network migration, power optimization, thermal efficiency, DCIM enablement. This video will provide an introduction to these environments and challenges of the data center. Physical security in the data center is addressed with macro segmentation using a six-layered approach. Perimeter is the first level of defense. The clear zone. The facade and reception. The service corridor. The data hall. The data cabinet. The network, IT, and structured cabling systems in a data center commence at the entrance room and carry through to the main distribution area, horizontal distribution area, and then to the equipment distribution area. The intelligent power chain that is critical to data center operation includes the medium voltage entrance feed from the utility, backup generators, battery rooms, UPS systems, underfloor and overhead power distribution cabinet level metered and monitored PDUs, and finally leading to managed IT equipment power. Environmental control of the data center facility starts with the chiller room, then leads to the computer room air conditioning and handling units, into the data hall with managed airflow to cool the hot zones via a number of contained cooling technologies.
Now, if you have cooling systems surrounding this data center, do you think the data centers will be very silent inside? You sure? See, when large amounts of these data nodes are assembled at a limited area, it will generate lots of heat. So they have to provide cooling mechanism in order to control that heat, right? When these cooling mechanisms are placed everywhere surrounding the processing units in the data center, do you think the data centers will be very silent? Large amounts of noise will be generated. The cooling systems will not only be around near the roof or on the walls, but the cooling system is placed under the floor also in order to provide cooling from all sides. So whenever you take some 25,000 square feet of data center, you will have lot of cooling mechanisms to be put in place in order to control the heat, as well as the data centers get large amounts of power bills, right? Current bills will be very high. Say for 25,000 square feet of data center, it generates around 5 to 10 lakh rupees of power bill every month.
To meet the specific requirements of the varying IT loads that generate temperatures that need to be managed carefully. Finally, this unique technical operation requires data center infrastructure management processes that deal with asset management, power monitoring, environmental monitoring, change management.
So you can imagine yourself here. You have to manage not only within the data center, but you have to monitor its working by continuous. It's like a continuous process. So you can imagine yourself as a man sitting here who monitors the entire working of the data center.
management and capacity planning to ensure that maximum uptime, scalability, and performance is achieved. More detailed information, webinars, and technical reports of the areas covered in this video can be found at annexter.com/datacenter.
Now you can see this, how actually the noise will be within the data center. When you're going to work inside.
Hi, my name is Sandeep, a developer advocate on the Google Cloud Platform. Welcome to the Google Data Center at the Dalles, Oregon. Take a look around. Before we go inside, we need to make sure that we have the appropriate security clearance. Most Google employees can't even get in here. So let's go on a special behind-the-scenes tour. I'm here with Noah from the Site Reliability Engineering team. Noah, can you tell us a little bit more about the SRE role at Google?
Yeah, SREs write and maintain the software systems designed to keep our services running.
So what happens if one of these systems goes down?
We've designed our systems from the ground up to be able to handle any unexpected failures that may occur. We have highly redundant power, networking, and serving domains, so even if we do lose
Now, did you notice here they're saying redundant networking and power domain? So nowhere the clients can afford interruption in their access to the data. So any data center or any storage infrastructure providing companies should see that they have backups, efficient backups, so that if the main line of the systems fail, immediately the secondary backup should be in its place within fractions of seconds, so that they ensure business continuity.
Lose an entire cluster, we're able to redirect those workloads and live migrate data in order to minimize any impact. In addition, we have a team of SREs on call 24/7 that can tackle any problems that might arise.
Thanks, Noah. So now we learned more about the systems that manage our fleet at Google. Let's take a deeper look at the data center infrastructure itself. Welcome inside. Before we can continue further, we need to go through the biometric iris scan and circle lock. These only allow one person in at a time and require dual authentication to continue further. I'll see you on the other side. Welcome to the data center floor. As you can tell, we have a lot of servers, and this is a single cluster in a single floor in a single building. Managing all of these servers on a global scale is quite a challenge. To utilize our fleet, we use tools such as Borg, Colossus, and Spanner. You may be familiar with similar tools such as Kubernetes, Google Cloud Storage, and BigQuery. Now, these tools allow Google engineers and cloud customers to more easily manage infrastructure, allowing everyone to build innovative and scalable applications. Here at Google, a lot of our infrastructure.
You can see a lot of sound is being generated here, right? That is because of the cooling systems as well as the processing units. They make some sound which adds to the sound of the cooling systems and makes the environment entirely noisy.
Infrastructure is custom made. This gives us the flexibility and performance we need to run all of our services at scale. Oh, hey, it's Virginia, one of our network engineers.
Hey, Cindy.
Virginia, what are you working on today?
Today I'm working with hardware ops to expand this data center network to deploy additional machines in this building. Our fleet is constantly growing to support new.
Now imagine an organization's requirement increases. Say the organization is expanding not only in India but throughout the globe. Then the organization's requirement of storage of their data increases as the volumes of data increase. Right? In such cases, they may have to expand their storage capacity. In such cases, they can just place their demand with the service provider, and immediately it can be scaled up so that more data can be accommodated from that organization. Now, on these clusters, on these data centers, they contain lots of clusters which contain racks that host these data nodes. Now, whenever some extra nodes have to be added, they can simply be added and plugged in order to sync with the other nodes that are already existing, and that's it. That is how they increase the capacity of the data center.
Capacity for Google products and our cloud customers.
That sounds like a lot of work to be constantly adding capacity around the globe.
Well, we've designed our network so that this kind of capacity growth isn't very hard. Jupyter, our current data center network technology, is a hierarchical design using software-defined networking principles. So just like with our servers, we abstracted away the specific details of our network and can manage them like they're software programs and data.
Abstracting seems to be a common theme.
Now, say there is an interruption in the network somewhere here. I'm pointing out somewhere here. Say you can see data center managers roaming between these racks in order to establish or reconnect if a connection is lost, or they will just keep roaming with their laptops in order to find out where which node has actually raised this interruption, or is there any issue with any of the nodes on the racks. They'll try to find out that and restore the functionality by either taking up another node into the network or by restoring the functionality of the same failed node.
Here at Google, I've also noticed a lot of fiber running in our data centers.
That's right. A single building can support 75,000 machines and carry over 1 petabit per second of bandwidth, which is actually more than on the entire internet.
Wow.
This allows us to reliably access storage and compute resources with low latency and high throughput.
So how is this data center connected to all our other data centers around the globe?
Google runs V4, our own private, highly efficient backbone network, which is actually growing faster than our internet-facing network. It connects all our data centers together and allows services to efficiently access resources in any location.
Nice. I finally know what all this Google Fiber is really used for. Thanks, Virginia.
No problem.
So now you've seen all the compute and networking horsepower required to run your workloads in the cloud. Let's take a look at where your data is safely and securely stored. Let's go. Whether you're querying terabytes of data on BigQuery or storing petabytes in Google Cloud Storage, all of your data needs to be stored on a physical device. Our data center infrastructure allows us to access our storage quickly and securely. At our scale, we need to handle hard drive and SSD failure on a daily basis. While your data is replicated and safe, we need to destroy or recycle used hard drives so no one can access your data. From the time a disk is removed from a server to the time it's decommissioned, we maintain a very strict chain of custody. The disks are completely wiped and then destroyed in a huge shredder. Let's go shred some hard drives.
So you can see that even after the client completes his agreement or contract, now he may have a doubt how secure is his data that is stored at the data centers. So they ensure that your data is completely shredded and destroyed once you stop being a client for that storage service provider.
We've looked at a lot of the hardware that runs in our data centers, but it doesn't end there. We need to cool and power our infrastructure in an environmentally sustainable and reliable way. Let's take a look at how we cool our servers.
Now again, note this point, they want to maintain the data center in an environmental friendly and sustainable manner. So you might have heard about Google and Microsoft thinking to establish their data centers in Antarctica, where the weather is very cool. right? And in minus degrees, and even under the water data centers. So the cooling, money spent on this cooling mechanism can be reduced.
Welcome to the mechanical equipment room. Looks pretty cool, doesn't it? Oh, hey, it's Brian, one of our data center facilities technicians. Hey, Brian. Brian, can you tell us a little bit more about this room?
Sure, well, this is a cooling plant for one of the data centers that we have on site. So a lot of heat is generated on the server floor, and that all has to be removed, and that starts right here in the cooling plant. So it's basically two loops. We have the condenser water loop, and we have the process water loop. The process water loop are these blue and red pipes over here. So they take the heat off the server floor, and they transfer it to these heat exchangers here. The condenser water loop are these green and yellow pipes here. They take the cold water from the basin underneath us, they transfer it to these heat exchangers here, and they send it up to the cooling towers up on the roof.
I noticed our pipes are Google colors. It's pretty cool. So how efficient is our data center?
Well, Google has some of the most efficient data centers in the world. In fact, when we started reporting our power usage effectiveness, or our PUE, in 2008, most other data centers were around 100% overhead. At that point in time, Google was 20% overhead, but since then, we reduced it to just 12%. And that even includes our cafeterias.
Whoa, that is so low. Also, what's this big green machine for?
Oh, well, this is a chiller. We very rarely use them, but it helps keep the process water temperature in the desired temperature range when it gets really hot outside, basically helping the cooling tower do its job. In some of our newer data centers, they have no chillers at all.
I love how our new data centers are even more efficient. By the way, can we go up and take a look at a cooling tower?
Sure, let's go.
Wow, what a view up here. Wow, what a view up here.
And note students, you don't have any explanation or content covered on this cooling mechanism in your course, but still it is an integral part of the data center. So it is not a wrong thing to just know about how the entire infrastructure of the data center looks like.
So Sandeep, this is a cooling tower. It uses evaporation to rapidly cool the water from the condenser loop and sends it back down to the basin. You could say we're making actual clouds with the cloud.
Clouds making actual clouds. Welcome to Google. So Brian, how do we power the cloud?
Well, that all starts at Google's Power Substations. Let's go take a look. So this is the Google-owned power substation. This is where the high voltage power enters the site, it's reduced, and then sent to multiple power distribution centers such as this one right here.
What happens if a power distribution center loses power?
If it loses power, we have multiple generator and utility backup sources available to maintain power to those servers.
And where does all the power come from?
It actually comes from multiple hydroelectric power plants that are nearby.
I love how Google uses reliable green energy whenever possible.
We are 100% carbon neutral, actually.
That's pretty cool. You know, it seems like Google builds reliability from the ground up, from the power and cooling all the way to the software systems that manage our fleet. Thanks for showing me around, Brian.
No problem. Have a great day.
Thank you for joining me on this special behind-the-scenes tour. Please check out cloud.google.com to learn how you can build what's next.
So now you have an idea about what you're going to learn in this course, students?
How does the internet work? The video you are watching.
Pavitra, Kavya? Now the stage has been interestingly set, right? So in order to study this course, you're not starting with interest on marks, or you're not starting with some namesake intention to study this course. You have to have that inquisitiveness, curiosity, passion to go into depth of this course now. Now you will be learning about how each and every part of this data center works, except that cooling mechanism, right? So you will study about various architectures, how the data is hosted, how the data is duplicated, how continuous access to the data is provided. Right, all these you're going to learn throughout this course. So let's start freshly from Monday with offline classes. And there is only one textbook prescribed, Information Storage and Management by Somsundaram. Right? As soon as you come to the college, better pick the books from the library, otherwise they'll be taken by some other students of other branches. So textbooks may not be available. And I'm not going to provide you any notes in this subject because the textbook, only one single prescribed textbook is there, and you can easily understand the concepts if you are attentive in the class. So I'm not going to provide you any notes on this. You should get it from the textbook itself. Okay, we'll end the class today. Just give me your names, because elective students may keep switching from one subject to another subject for another 1 or 2 days. We have not written your names in the attendance register. So I'll just take down your names for some days. Once the students are frozen in respective elective subjects, then I'll take the attendance. You can just respond with your names quickly.
Sunil Hajim.
Yes.
Guria.
Asta, Guria.
Ma'am, Deepika LG.
Kavya ma'am.
Srinivas.
Kavya.
Ramya ma'am.
Ramya.
Pavitra ma'am.
Srinivas, Pavitra.
Kishore present, ma'am.
Kishore. That's all?
Ma'am, Kishore, ma'am.
Yes, Kishore, I have written your name. 2, 4, 5. Yeah. But make sure that you attend the classes regularly. Otherwise, you will miss the continuity, because lots of architectures we are going to discuss. And this will not be very boring. The subject is not dry. It's very interesting. Okay, so if you miss any class in the middle, you will lose the continuity and you will not be able to understand the other parts of the course. So don't miss the classes. Be regular to the classes and you will enjoy the course. I ensure that. Okay, we'll meet in offline classes from Monday.